Welcome to Engineering Scale Models. I'm Jason, your host, and I do models and electronics. Today we're back with our soldering tutorial, where I only have a half an hour to get as much done as possible. So let's see where we are. Yesterday, or the last episode, we got these 1206 resistors on. We're going to flip the board over, and we're going to put on some 805 resistors, which is this group here, and we're going to try to get that done within a half an hour. So let's see if we can find the 805 resistors. We have a little guide here for 805. That could be the 805s. That's the 1206s we used. So yeah, these are the 805s. So I want to put the rest of this stuff back in the baggie. And we're going to put on all these 805 resistors. Now, far I've been a minute into this, and hopefully I can get this done. So I want to put my board in my board holder, like so. And I'm going to tin one side of all these pads, sit all the components on, and then hopefully be able to reflow them with the hot air. So turn on my micro pencil, using a Hacko FX951 station and a FM 2032 micro pencil with a 0.6 millimeter chisel tip. And I'm going to be using Kingbo RMA 218 flux today. So let's go under the microscope here. Let's see, here we go. So we're going to tin one half of these pads, starting with up there. So I'm coming here with my micro pencil and my solder. I'm using a little thicker solder this time. So we're going to tin these pads here. These pads tinned. Turn on my fume extraction. Clean my tip. This is a very time-consuming process, but I have a plan for this board when it is done that will be very interesting for those of you who work on repairs, because I plan on transporting all these components from one board to another using various methods. So, like, this will be the donor board, and then I'll have a new board that I'll transfer each component from. So that will be interesting. Especially transporting the LEDs. I may need to use the hot plate to transport those. All right, so we have all the pads tinned. Come up here to the beginning. And then we're going to get our resistors out. Well, all those resistors out. Then I'm going to start lining them up on my board here so I can grab them. Flipping them over here. I do this while my tweezers aren't covered in flux. Because in the last episode, my tweezers were covered in flux. And it was difficult to do this. So is all lined up here. Now, this seems like it's taking a while, but it'll save time in the long run, so I'm not messing with every single resistor individually, especially when the tweezers are all covered in flux. All right, so I'm going to take my first resistor here, just switch back over this, place my resistor down, go in the wrong direction. Let's stick that resistor on there like that. My next one. On there. These things are tiny, so it's hard to see the orientation. You remember from the last video, it doesn't matter if they're out of alignment now, because they will get in alignment when I use the hot air and the flux. The first one I grabbed in a bit, that was upside down. Oh, no, I didn't lose it. No, but I flipped it over. Okay, here we go. So very delicate one. But I have shaky hands. And a lot of people that do this have shaky hands. So everybody can do it. Just takes practice. And again, I know this doesn't look the best right now because I'm not using flux to reflow these joints, but that will all change. So that is that row of those components. I don't think there's going to be enough of these components. I really don't. So I'm going to get this next row out. I'll show you what I'm doing here. So I'm just going to sit here and get these all lined up. So now I have the flux on my tweezers, so it's going to be a little difficult. So I'm going to switch to a clean pair of tweezers. Okay, so I got these. I'm going to try these other tweezers here. These are Hacko tweezers. These are my scale modeling tweezers. I'm going to try these Hacko tweezers. Let's see how they do. All right, so now we're going to come back down here and reposition us so we can see all of that. And we're going to continue to install these resistors. Like so. Also helps if you rest your hand that the tweezers are in on the bench, and you can get a little bit better, steadier grip. Works better for some than others. But so I recently was working on a daughter board project to replace some obsolete chips on a piece of manufacturing equipment. So I haven't really had a whole lot going on. I got those 3 switches fixed. Well, a total of 5 switches have been fixed, but 2 have been sold. But two of them were easy fixes that didn't require any board level work. Well, one was an EMI filter, but that was that was cake. I may even changed it on a stream. So that was cake work. So two of them have sold, and then I'm shipping number 1006 today. So I plan on getting 2 more no power switches, just like number 6. In a couple days, I'm gonna order them. I even order them on a stream. They're actually not no power. They're damaged charge ports, but they were $100 for a damaged charge port, and number 106 was a damaged charge port, and it turned out to be liquid damage, but it didn't turn out to be that bad, and all it required was a charge port, and I paid $108 with shipping for the unit, and then I sold it for $250. So, I made $140 on it in a few hours of work. So, it's not excellent money, but it allows me to buy 2 more of those and hopefully do the same thing to those. And then have some stuff, have some extra stuff to work on for you guys. Most of the stuff I work on is side projects. I film most of that stuff. I don't if I have a contract or something for some kind of engineering task, I don't film that because it's a complex, daunting process on its own right. And if I recorded the entire time I did stuff on it, it would be multiple terabytes of video, and I would have to edit it all, and most of it wouldn't be understanding anyways, because it's not a skill that is transferred to other fields. Replacing a obsolete chip with new chips in a daughter board is every task is different in its own right. None of them are the same because every chip is different, and they're all specialized chips anyways. They're just out of manufacture, so we have to replace it with a newer modern chip, which if the machine is old, the old chip ran on a different voltage for the logic, and the logic was different, so the timings were different. So it, spawns a world of just, trying to boost data signals. And then you boost the data signal, or you step down the data signal so it reaches the criteria. And then you run into an issue with timing because, it's not in the timing window of the next thing down the line on the circuit. So you have to work on that, or start over and use a different chip that I can do it. But you also have to keep in mind that the chip that you use to replace it, you want to make sure that's not going to be obsolete in a year or 2 or 3 years. You want to make sure it's a chip that's going to be used for a good period of time, because if you replace it with a chip that's obsolete in, say, a year or 6 months, you're going to be giving yourself a lot of work to do in a short amount of time. Again, and then, the company you do it for may not appreciate you using that chip and then having to pay you to redo it again. So it doesn't seem like I have enough 101 resistors here. We're going to have to check the packet. Now I flipped that around. It didn't need to be flipped around. Nice thing about this micro pencil is it's so tiny that you can flip components with it too. That was way out. 21 minutes, so I got to get moving here. I'm going to get this done within 30 minutes. May have to do the reflow of it first thing next video. I need to try to find these other components. One right here. So we're missing 5. Oops, 4. Missing 4 101 resistors now. Wait a minute. There we go. I got 1, 2 more I found. And this one. Now, let me just look here to see if there are any more that got scattered about. I'm going to take this off and show you this camera here. Now, I said in the last video, I'm doing this in 30-minute bites because my back and shoulder is not the best it could be. So I only can do so much. Is there another step? I think there is. I think there's another strip in here. What do they say? No, they're 103s. Threes too. So no more of them. So what I'm going to do is I'm going to get out my 0805 resistors. Is that 0805? Yeah, I'm going to get out my 0805 resistor book. Just right here. And then 101 is 10 with 10, so 100 ohm resistor. So I'm going to flip through here and I'm going to find 100 ohm resistors. 100 ohm resistors should be 101. Pull out a strip of that. Let's check them under the scope here. Oh, these are 4-band. These are 4-number resistors. I hate that. Okay, so let's put those back. We're going to leave those 2 resistors off and see if I come across them. Because I don't want it to be out of place with the type of resistors. And I may have some somewhere else. So let's go back to the scope and put solder on the other side of all these. So let's go this way. We're going to flip it. We're going to come in here like so. If you can see all that. Hit my solder. Clean the tip. Solder. 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 The solder has flux in it, so it'll help flow a little bit, but so I'm going to reflow. I'm going to reflow all this with the hot air. That was real bad. too much on it, but they said when we reflow it with hot air, it's got these last two rows here. All right, so there's that. So let us let's go over here. You see how high I can go to get as much as this is in view as possible for when I do the hot air reflow. Okay, so we're going to do all those right now. So I'm going to take this flux. I got to do this quick. So I'm going to gingerly apply this flux to this board. And this is Kingbo RMA 218. All right, so we got the flux on there. I'm going to come in here with my hot air gun, set at 40 airflow, 480. And I'm just going to come in here. I'm going to hold my tweezers, and I'm going to come in here at an angle here, and we're going to start to reflow these joints here. Get them all nice and pretty. See how they set down there? And get these to set. All these to sit. Some of those have a little big pads of solder on there, but that's it for this. They are reflowed. Here's the links. Here's the link to Patreon. Thank you for watching. Have a fantastic day.